Hello techies. Today we are discussing about how to create AWS EKS cluster with the Fargate option from the console. So here are the steps we will follow in this video to achieve this. So we're gonna create four resources like two AMA roles and one cluster and one Fargate profile. So before we get into these steps, I want to show you about the architecture of EKS. So basically, you all know Kubernetes will run as master node concept. So it is the master node which you have all these components, and these are the slave nodes we can call. So if we took EKS option, any cloud service, we take the Kubernetes EKS or EKS for Azure. These master node will taken care by the cloud provider itself. Now the Amazon. So if we take EKS option, we don't need to worry about the master node configurations, health and everything. Everything will be taken care of by the EKS, I mean Amazon itself. So we have to worry about the node configuration. So here also, like, let me open this. So this is what the node group. We have two options in the EKS cluster. One is node group and one is AWS Fargate. So if we take node group, again we need to consider all the um, infrastructure related things for the servers. Like as the worker nodes are the physical servers, which you can see from the EC2 console. So you have to monitor the servers and you have to attach the desired capacity to the servers. And the second option is AWS Fargate, which we're gonna discuss. The If we take this option, our worker nodes also will be taken care by the AWS itself. So if we take AWS EKS like with Fargate option, so we don't need to worry about the infrastructure at all. That includes the master node and slave nodes or worker nodes, whatever we call. Okay, let's get into our steps first. So we have to create two AMA roles for this process. One is for the creation of EKS cluster and one is for the creation of Fargate profile. I think these two we will create in ongoing process itself. So first we'll go to the EKS cluster. Then at the point of allocating the AMA role, we'll create the role for the cluster. Okay, perfect. Let's get into the Amazon console and just search for the EKS service, Elastic Kubernetes service. Yep. And here are the clusters. So we don't have any cluster yet, so just add cluster and then create. And it involves six steps. You can see here: configuring cluster, specifying networking, configure logging, select add-ons, configure selected add-on settings, review and create. So basically 6 steps. So okay, for the name, let's say demo cluster, and we need to select to the appropriate Kubernetes version. So 1.27 is the latest, and latest will be taken by the default. Okay, and yeah, this is the role we need to create. So as I'm already created, it will showing here, but anyhow we'll create a new role for now. For this, let me open my IAM console here. Click on roles, click on create role, and we are creating a role for the EKS service, right? So which is one AWS service. So choose here EKS, and in EKS we are creating cluster, right? So EKS cluster, click on next. So defaultly the Amazon managed policy will be attached, Amazon EKS cluster policy. Okay, just click on next. You have to give the name. So demo cluster role. I think I already have this name. Let me check. Demo cluster role. Yes. So we'll create. Just put one here. Just review. and click on create role. It will create a role for us. Yeah? View role. Yep, it was created. So go to the EKS cluster where we stopped. Just do a refresh. So here two roles. This is one we just created, right? Demo cluster role one. Okay. And next secrets encryption. So this is more related to the adding KMS, customized KMS key to the cluster. So this will keep your Kubernetes secrets at encryption. Okay, if you wish to on this, you can on. But as for now, for the demo purpose, I'm going with default. Click on next. Step 2, networking. So which is important again. So for the VPC, I have already created the networking. So I'm just selecting the VPC, and by defaultly all the subnets in VPC appear here. You need to select if you have any specific subnets, like if you want to host your EKS cluster only in private zone, so you can remove these public ones. You have to put only private subnets, or if you want to put the public subnets also for the EKS cluster, you can choose. And next is security group. So here one important thing is the cluster, whatever we are adding security group here, we are selecting a security group here. This is gonna be additional security group. Let's say I'm just selecting the default security group here. So this will be an additional security group for the cluster. The main security group will be created by the cluster itself. While creating the cluster itself, it will create a security group and attach the necessary rules. I'll show you that security group ID once the cluster was created. But this is the additional security group that if you wish to add, you can add. And the cluster endpoint access, again we have three options here. So public and private. If you choose public, the cluster endpoint, which is the API endpoint we call it. So the cluster endpoint is accessible outside of your VPC. Okay. And the worker node traffic will also leave your VPC to connect to the endpoint. I mean, the worker node has to connect to the API endpoint. So this will, let me show you by using this diagram. So if the nodes are trying to access the API server, this traffic will out of your VPC. This traffic will work out of your VPC if you select public. Okay. So if you select public and private, the cluster endpoint is accessible outside the VPC, but the worker node traffic which are going to the endpoint will stay within VPC. Okay. And if you choose private, everything would be under your VPC only. The cluster endpoint and everything, the worker node traffic, everything stays within your VPC only. So for the demo purpose, I chose public. Even though if you choose public, you have an option to add CIDR block here. Like let's say if you want choose public here, but you want to restrict the access from the all sources. So then you may mention your desired CIDR block here. Okay. So for I'm just leaving as 000 all networks. Just click next. And step 3 is configure logging. So control plane logins. So what are the components you need for the logs, you can enable those. So for the demo purpose, I'm not enabling those. Next, click on next. And add-ons, EKS will support several add-ons. So some are defaultly created with creation of cluster. So code DNS, and these are you can see. So just click on next. And this is the version of the add-ons. We have selected a Q proxy code DNS. These versions will be attached to our cluster, the default versions. Okay, click on next. And the final page, you have to review all your configurations, networking configurations, endpoint access and logs and add-ons and everything. If all are as expected, just click on create. Yes, now we are, it is in creating status. So you can see these pop-ups: manage node group or Fargate profile cannot be added. So once we have cluster was created, then only the option to add Fargate profile or node group will be enabled. So it will take a couple of minutes. So yes, now it was created. So it took almost 7 to 8 minutes. So now it was created. It was the status was active. So click on the cluster. So you can see the next step is provision compute capacity for cluster, adding manage node group or creating a Fargate profile. We'll do that. So before that, click on networking tab. So you can see here, this is the additional security group we added while creating the cluster. But this security group, let me open this, was created by the cluster itself. Okay. So let me open this. You can see the description also. EKS created this security group. Apply to some EKS control panel nodes. Okay. So as I said before, this security group was created by cluster itself, and the additional security group we added while creating. Okay. So yeah, click on compute. So we have two options here, as I said earlier. One is node group, and then is Fargate profile. So as we are discussing about Fargate profile, just click on add Fargate profile, and yeah, it is again three-step process. Give a name, say demo Fargate, and here it requires a pod execution role, which will have the privilege like to pull container image from the ECR and etc. And we will create this pod execution role now itself. Just click on the user guide here. What I like most in Amazon AWS is they have very crystal clear documentation for everything. So you'll find almost 80% of your solutions on official document itself. And it was also very clear. You can see like open console and on the roles page and click on, and so it was very we should blind follow. I mean, we can follow these steps. Yeah, here from the console. Open console, they have given the link also. Click on roles, create new roles, select trust entity, so blah blah. Yeah. So we will directly go to the IAM console and we'll create one role. Yes, we are in the IAM page. So select roles, same create role. Again the AWS service itself. Again we are creating a role for the EKS, right? Okay, EKS, click on EKS. But for this time, we are creating the role for the Fargate, right? Fargate pod. Allow access to other AWS service resources that are required to run EKS pods on Fargate. We need to select that option and click on next. So by default, it will take this policy, Amazon EKS Fargate execution role policy, which is also again the AWS managed policy. If you expand this policy, you can see the ECR related permissions here and click on next. Role name demo Fargate, sorry, demo Fargate role. Okay, and in this trusted entity, so as you can see in the documentation, where it is, okay, let me open again. There is a condition we will add. Let me show you. Yes, if you wish to add a condition like to specific cluster and specific Fargate profile, we need to add in the trust entity. You can add, but this is again optional one only. So I'm going with EKS Fargate pod.amazon.com. This permission only. I'm not adding any condition to this. Like any condition in the sense like if the ARN meets this specific requirement, then only it should allow. So I'm not going to follow this as of now. So click on create role. It will create a role for us. Just view role. Yep, the rule was created and the policy was attached. Perfect. Just go to the Fargate option where we stop. Just do a refresh and drop down. Oh, it was already there. Okay. And for the subnet, here is one thing important we need to remember. The Fargate itself, it will take only private subnets. It will not take public subnets, because end of the day we will host, I mean our application will run these nodes only, like the pods and containers, everything will in these nodes, Fargate nodes only. So to isolate our application from the internet, the default it will allocate the private one only. You can see there is no option to select the public subnets also. So only the private subnets will be selected. Okay, and click on next. And another important thing is you need to allocate namespace to this Fargate profile. So what will happen is, let's say if I allocate something like dev namespace here, so what are the deployments I will do in dev namespace, those will consider as a Fargate, like those will have the Fargate serverless nodes. So if I deploy anything rather than these namespaces like dev or in, which was I am attaching here, it will not be considered as a Fargate option. So we have to be sure we have to allocate all namespaces. Let's say dev and testing. So let's say I want to add another namespace like the default namespace also here. Yes, cube system, because the default ports, the default deployment code DNS which was in cube system itself, right? So I'm attaching that, and additionally I'm attaching these two namespaces because these I will use further for the deployments. Click on next. Just review your configuration, the mainly subnets and role, and here the namespaces. Just click on create. Fargate profile creation is in progress. Okay, port selector, we have the namespaces, right? Yep. And again this will take a couple of minutes. So yes, the Fargate profile is created. It took almost 3 to 5 minutes of time. So yes, the Fargate profile is now active. You can see here. So we are done with the creation of cluster along with the Fargate profile, and we attached namespaces here also. So let me quickly connect to the cluster using one EC2. So let me go to the resource. Here you can see all resources, pods, deployments, everything. So here we have the default deployment code DNS, which will have the two pods. Okay, yeah, let me connect to this cluster once. So to connect to the cluster, we need to connect to the cluster using AWS CLI command, which is AWS EKS update kube config. So we need to give the name, our cluster name, demo cluster. You can enter. Yep, the kube config was saved into our system. So then simply kubectl, let me, yep, kubectl get pods -a. So we will have the default pods which is in default names as cube system. So those are in pending state. Why? Because the pods are defaultly set for the EC2, I mean the node group. So the annotation in the deployment, the default deployment was like that only. So we need to remove those annotations from the default deployment, which we can achieve from the patching kubectl patch command. Let me copy this command. So here we are just removing the type. The default it will be the EC2. We are patching the default deployment by removing the path. So let me do that. Yep, the default deployment was patched. You can see here. So let me clear the screen and kubectl get ports. So we'll do a watch here. -w. Sorry. Yes. So it has to create. I mean, the ports has to. The status has to be in running, and we can monitor these from the console itself, as we have the console also here. So just do a refresh here in our cluster, go to resources and pods here, and you can see this is the latest pod. We can see the events also. Okay, it was saying logging is disabled. Okay, anyhow we have not enabled that. And the Fargate profile is demo Fargate profile. Yes, yeah, you can see here it was running, the pod status was running. So now it can able to fetch the Fargate profile, and we can able to create the serverless node running. So let me kubectl get nodes. We have two nodes. Yes, so these two are Fargate nodes. So before that we don't have any nodes. So now the nodes were created, those are also serverless. You can see same thing from the console itself. Go to the compute. Okay, go to the cluster and go to the compute tab. Just do a refresh. Yes, these two are the nodes. These two are serverless nodes. If you want, you can check from the EC2 console. There will be no servers in EC2 console, as those are like instances. You can see there is only one server which I connected just to connect to the cluster. So okay, I will give these two commands in the description. This command will be used to connect to the cluster, and after connecting we need to run a patch command for the core DNS default deployment. Yes, we are. Just a minute. Cubes. Okay. So now if you want to deploy any demo application in dev, or the three namespaces cube system dev or testing, which we are attached to the Fargate, it will defaultly take the Fargate option, and the serverless nodes will be created. And I will be show you the deployments in EKS cluster in the next video. Yes, in this video we just gone through these steps, and we connected to the cluster using the AWS CLI command, and the Fargate serverless nodes also created. Okay, thank you.